Hello everyone, welcome to College Current Stuff presentation on Microsoft.NET. So this is going to be a little longer presentation. I will try to pause uh, and answer your questions whenever you have. So let's delve deep. So what is .NET Framework? Okay, so the very definition of .NET Framework is the .NET Framework is an integral Windows component for building and running next generation of software applications and web services. Okay, so the keyword here is integral Windows component. Okay, yeah, so this component is actually shipped with Windows. Okay, so you don't need to download and reinstall it. It's available, I think, since Windows Vista, and I think in the server operating system since Windows 2008. So these are basically a set of DLLs or libraries that are installed on your operating system that run the .NET applications that you develop. Okay? I will explain in the due course in this presentation how .NET programs are different from the native Windows programs. Okay, so why .NET? Okay, so the first thing is there was no comprehensive one platform that could develop different types of applications. For example, a console application, a Windows desktop application, a web service, a website, or a Windows service that runs on the background. So it was not easy before the advent of .NET. So once .NET was developed and released, it provided us a single platform in which you can develop multiple types of applications. And I will show the demo using Visual Studio at the end of this presentation. And then it uses the same set of reusable classes for various types of applications too. And the next is it's the main problem Windows had was actually with memory management, and I think that's one of the key reasons why .NET Framework was invented, because memory management and management need to be very much sophisticated and advanced. So that's why they started this framework, and .NET Framework has a very good memory management system in it, including garbage collection and other things. And it's also a more secure environment to run applications where you cannot easily write virus-like programs and develop applications in multiple languages, which is like Visual Basic, C#, Visual C++, and make them completely interoperable. So that's one of the highlights of .NET Framework. And the code that runs in the .NET environment is called as managed code. Okay, and the native Windows code is called as unmanaged code. Okay, and the final one is like Java, all the programs are classes in .NET. Okay, so again, the exe that or the .NET DLL that we develop requires .NET Framework to be present on the machine to run. Okay, so I will explain why and all those things. So this is one of the key components of the .NET Framework called Common Language Runtime. This is called as the execution engine. Okay, what it does is when you double click an exe, what it does is it loads it loads the exe. Windows operating system loads the exe into the memory, and in the headers it checks if the exe is a .NET exe or a Windows native exe. If it's a Windows native exe, then Windows system takes care of it. If it's a .NET exe, it actually gives the handle to the .NET CLR, Common Language Runtime, and CLR takes over from there. This is the actual execution engine, and it copies that program to the managed memory segment, which is allocated to the .NET Framework, and then starts to execute the code and allocate the programs, allocate the memory for the variables, functions, and then it converts the .NET EXE by default will be in an intermediate language format called as MSIL, Microsoft Intermediate Language, and it JIT compiles them to native code. Okay, so these are the functions of CLR. Okay, um, the next is .NET also comes with base class libraries. These are the set of classes provided by Microsoft, which helps developers to reuse them and deliver their product much faster. Uh, Again, these classes are used for various purposes like reading files, parsing XML files, um, and then connecting to various types of data bases or data sources like files, etc. Okay, and these classes are physically grouped and stored into a files with the extension .dll, and then they are logically grouped into a namespaces, so that if you want to know where the classes related to files, directories are there, then the namespace will be system.io input output. Okay, so that namespace will have all the IO related classes in them. Okay, so it's a grouping, logical grouping. And the next one is a common type system. This is the reason why you can write your code application in multiple languages or components for your application in multiple programming languages targeting .NET framework. Okay, and they will work seamlessly. Okay. The common type system is a standard that all programming languages should implement so that code written in one can work with other. The main problem that we used to have with other programming languages was, like, for example, between even Java and .NET was, in Java the integer may be 2 bytes, but in .NET it can be 4 bytes. So these type of incompatibilities are the very basic reason why the interoperability between Java and integer was Java and C# was not that well. So in order to solve that problem, Microsoft said any language that is coded on .NET framework, okay, will have integer as a standard data type, which is like 4 bytes or something. Okay. So you have to understand this is the main reason why .NET framework languages are interoperable. So you can write a class in C# and a VB.NET application can consume that. So what happens when you compile and execute a .NET code? Okay, so you have a C# code. When you compile, it compiles into MSIL, DLL, or EXE, and then when you run it, it is converted into native code. So what happens is the OS loads the .NET program, and as I said, it checks the header to find out whether it's a native EXE or a .NET EXE, .NET code. If it is a .NET program, then it gives that to the handler to the common language runtime, and the common language runtime loads the program, allocates the memory, everything, and then it calls the JIT compiler to compile the method that is about to be executed. And then the JIT compiled method is compiled into native machine language code, and it's executed. Okay, the core DLL for the .NET, where CLR and these components reside, is ms_corelib.dll. Okay, and again, in .NET world, you will hear frequently managed memory. Okay, a managed memory is nothing but a separate address space allocated to .NET framework to execute .NET code. Okay, so in order to execute .NET code, you just operating system allocates a special memory space, highly secure, and .NET framework using CLR takes care of everything. Okay, in that memory space. Advantages of .NET framework. There is no need to register any DLLs developed in .NET. Previously, when we do it in the native world for using Visual C++, we have to run this command called reg svr32 or reg svr2, register a DLL, so that all the applications installed on that machine can use that. Now we don't need it. Okay, so I will explain how that is done now. And second one is the biggest one, is it increases developers' productivity dramatically. Okay, the .NET framework has huge set of reusable classes that will solve. Okay, that has already solved some of the problems that you might be expected to solve in your applications. Okay, and it also provides the ready-made logic, code, connectivity, everything. So it will increase the developers' productivity, and this is one of the best reasons why Visual Studio and Microsoft .NET are very, very, very popular. And again, the code that you are writing is compiled into MSIR format, so it can execute on both 32-bit and 64-bit, provided the dependency libraries used by these applications are also following the same format. You can have your exe, you don't need to compile it into two editions, 32-bit edition, 64-bit edition. Just give a MSIL edition and it will run on both 32 and 64-bit without any problems. And then side-by-side version, which is like you have a older version of the same program and then now you have a newer version of the same program. Both of them can coexist in different directories and run side by side, no problem. Okay. And then global assembly cache, as I said earlier, in the previous world we used to run the command called regsvr32, and then that DLL will be registered in the Windows registry, and then all the applications can reference the classes methods in that DLL, and the operating system knows where the DLL is through this registry. But to solve it simply, Microsoft .NET came up with something called global assembly cache, where you can either do the same register into global assembly cache, or you can keep it in a particular folder and specify that folder path in a config file for the applications to use. But global assembly cache, the standard .NET libraries are stored in global assembly cache so that you don't need to actually distribute them along with your applications, and you can assume that the .NET framework installed on the target machine already has these assemblies in the global cache. So, and then again, deployment, you don't even need to create a MSI file or anything to install. You just do an X copy, okay, like just zip file, extract it and start running it. Okay, and then rolling back to previous version, since it's X copy, if you have back to previous version you can do it. And also Microsoft has a technology called click once, that in that way you can even do a rollback to previous version from the control panel. Okay, so these are some of the features that you can take advantage of. Again, this is how your global assembly cache will look like. Again, this is from, I think, Windows 7 screenshot, but you can see these are the .NET DLLs that are registered in the global assembly cache. And then if you look carefully in the second column, you can see processor architecture. So some of the DLLs are still in MSIL format, and some of them are in 64-bit, compiled into 64-bit format. Okay, and some of them are compiled into the same assemblies, compiled into even 32-bit. Okay, so you can see them, and then you can see the versions of them, and I guess some of them may even have multiple versions. Yeah, you can look at that system.add-in DLL. You can see version 2.0 as well as 3.5. Okay, in the top, the fourth and the fifth. So this is how the global assembly cache will look like, and these are some of the system DLLs that your application will be using. Advantages of .NET framework: it has sophisticated debugging facilities. Okay, which is like it's very easy to debug everything using Visual Studio. That is the IDE, integrated development environment, that we will be using. And then it provides garbage collection, which is very, very efficient, and that really gives a boost to the performance of your applications when you run it. And advanced features to interact with databases to get large volumes of data, GBs of data, without crashing the memory. Okay, and again, this is one of the old features but still very useful, is generics, where you can have your classes, the type of your class, declared at a runtime. Okay, so that you can define a class as a number that can do addition, subtraction, multiplication and everything, and then you can declare what exactly is the type of that application class, what type you have to create. Basically, you going to create this for an integer, a float, or a scientific number. You can do that. And then again, .NET Framework is available in both 64-bit and 32-bit. And managed code is type safe, which means like it won't interact with the classes that it doesn't know much. And then even if you do it, if it's an unmanaged class, that will still be handled by native and cannot really read or write into the .NET framework very easily, memory very easily. Um, and then there is also a verification process to check. There's something called system policy where you can set such and such namespaces functions should not be executed on this machine. uh, and the .NET framework will actually, the JIT compiler will actually check it before even it gets JIT compiled. Okay, the CLR will check it. Okay, so this okay, these are the types of .NET applications that you can develop. Again, the one is console application, okay, which is more like a DOS text-based um, application where you can just enter values, press enter, and then do some processing. The Windows application is more like a GUI application, like Microsoft Word, Excel, and other things. And Windows Service, these are like a background programs that you can develop and install into the Windows Service framework, so that it can run continuously or it can get started on a particular event and other things. Okay, and then the web application, as you know, it's a website actually that you can develop using a framework called ASP.NET, and it works on it works on the web server called Internet Information Server. You need that to host your ASP.NET web application. Again, that comes with Windows. And the user can access that ASP.NET application using the browser, any browser. Okay, and it works for most of the browsers. A web service, these are like um, reusable classes that any application can consume on HTTP protocol. Okay, which is like which is exactly in two ways. One is using um, XML based protocol called SOAP, the other is a JSON one. Okay, and then the mobile applications with Windows operating systems, Windows mobile operating systems, you can develop applications for them too. So now Windows has the universal app store, which means like if you develop an app for app on the Windows framework, it works on most of the devices which run Windows. Okay, be it handheld, laptop, or anything. Okay, even I think some gaming systems and HoloLens that's coming up. Okay, what is assembly? An assembly, any compiled output in the .NET world is called as assembly. The assembly consists of following things. It consists of a MSIL code and the metadata about that MSIL code. Okay, and then the JIT compiler uses the metadata and the MSIL code in the DLL or the EXE. Okay, so for the JIT compiler to compile the MSIL into native code, it needs some more information. Okay, and that's what the metadata provides. Okay, and then nggen .exe. This is a very interesting thing. Every time when your application is loaded to the memory and it's executing, it has to go through JIT compilation. Okay, once, as long as it's on the memory. Okay, but still some applications can't afford to have even this performance lag. Okay, so most of the times, the first time when you deploy a .NET code and try to run it, when it loaded to memory, it will be slow, but in the second call it will be fast. It's because in the first time when you try to run it, the JIT compilation is happening. So what do you have to, in order to minimize the number of times the JIT compilation is supposed to happen, what you can do is, when you install your application on the target machine, you can call this utility that comes in the .NET framework called native generator nggen.exe and say, hey, I want these assemblies to be converted into native language on this machine, so that when they get loaded, they don't need to go through JIT compilation every time. Okay, so again, this is very, very good practice if your DLL is going to be used by multiple applications on the same server or same system. Okay, so think about it. Again, this is done during the deployment on the target machine. Okay, not in your source machine. You should not supposed to do it in your source machine and port those DLLs to the target machine. Okay, because your source machine may be 64-bit, but the target machine may be 32-bit. And if you do native generation on 64-bit and try to run the DLL on 32-bit, it will fail. Okay, dependency. So if you have any DLLs, uh, if your application uses any DLL, any other DLLs, then it has to be present in the same folder as the application, or it has to be in the global assembly cache. And there is a way to specify the where to look for those DLLs in a file called config. Okay, and then if you want to register your assembly in the global assembly cache, you can use it, do it using gsutil.exe. Okay, and again, it's not a straightforward process. You have to first make that assembly into a strong name assembly using a key and a command, and then you have to register them in the CAC. Okay, and the native code, as such, any microprocessor classes you might have taken would say that any code that executes has 3 segments: data segment where your variables are stored, code segment, okay, where the actual instructions are stored, and the stack segment where your variables are popped in and popped out for a temporary swapping. Okay, so thank you, and then I'm going to show you some basic demo of how to do hello world and other things in different types of applications, okay, in the following video, and then we will take it from there. Thank you.